This is Guided Practice 12. We're working on 7.3 trig sub, and we're working on number 2. So we just finished number 1, and we're tackling number 2. So again, we're looking at what's inside the square root, which is the t squared plus 1. So this is going to be our substitution for tangent. So we're going to let x equal tangent theta. Right? Our a here is 1. So we're going to use just tangent theta. Dx, then, we're letting t, let's get our variables right. We're letting t be tangent theta. Then dt is secant squared theta d theta. Okay, and we're going to sub. So we get the integral t, which is tangent theta, over square root of tangent squared theta plus 1 times secant squared theta d theta. Okay, now tangent squared plus 1 is secant squared. So we get the integral of tangent theta over the square root of secant theta times secant squared, wait, there's a square there, secant squared theta d theta. Then take the square root. So I have the tangent theta over the secant theta times secant squared. One of those secants cancels, so the 2 cancels with that one. And I'm left with just the integral of secant theta, tangent theta, d theta. And the antiderivative of that is secant theta, plus a constant. Okay, now we're going to use our substitution to create our triangle and find secant theta. So we know that tangent theta is equal to t over 1, because we don't have a number there. So our triangle for theta, tangent is opposite over adjacent. So the t is opposite and the 1 is adjacent. And if you find your c, right, that's t squared plus 1 equals c squared. So c is the square root of t squared plus 1. So when we're finding secant theta is 1 over cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And so in that case, the hypotenuse is our square root of t squared plus 1 divided by the adjacent side, which is just 1. So we just get the square root of t squared plus 1 plus c. Okay, so that one actually simplified rather nicely. So that's number 2.